Right. Hey everyone. So this is going to be the question balanced. And so what's going to happen here is we're going to check if each branch has the same sum of all the elements and if each branch is balanced. So first, let's take a look at the doc test to see like what's going on. And so if we see like this tree, so this corresponds to like the first doc test. If we call balanced on it, it's going to return true. And so the reason behind that is the sum of this branch is 3, sum of this branch is 3, sum of this branch is 3. So that check is satisfied. And then after that, what we want to check is we want to make sure each of the branches are balanced. Because if one of the branches aren't balanced, then the entire tree is not balanced. So we check the 3 tree. It kind of has no branches, so it has to be balanced. And then we check the 1 branch. It only has like 1 branch. So one branch has like the same sum across all branches. So therefore that's balanced along with this 2 tree right here. Because we want to check if like the trees of trees, branches of branches are balanced. And so that's also balanced. Same with this tree right here. 1 and 1 are equal. So that's balanced. And if we make we want to check if each individual branch is balanced. The 1 isn't balanced because like there are no branches. And this one is balanced as well. And so we want to check if each branch is the same sum of all elements. And then along with that, we want to check if each branch is balanced. Well, since we're checking if each branch is balanced, that kind of gives us the idea that, it should probably be a recursive call. And so because of that, what we want to do is we want to check maybe for each branch, we want to check if it's balanced. And since we check if it's balanced, that kind of like refers to like a recursive call because balance of t is going to check if this branch is balanced and everything like that. And along with that, we also have sum tree, which is going to give us the sum of the tree, which is pretty convenient because we actually do have to check the sums. It's like 3 right here, the sums of these branches. And so one thing I want to point out is like there are a bunch of ways you can like make comparisons between like the branches. But one way you could do it is, so this is going to be 3, this is going to be 3, this is going to be 3. Well, since they all have to be equal, they also all have to be equal to like the first branch. So maybe we could compare each branch's sum to the first branch's sum and see if they're equal. Because if it's not equal, imagine this might be a 2, then this tree is definitely not balanced and we can return false in that case. And so yeah, so what we can do is for each branch, along with checking if it's balanced, check if sum is equal to sum of the first branch. Because if it's not equal to, then we're going to return false. And along with that, if that branch is not balanced, we're also going to return false. And so along with that, let's think about like what our base case might be. And so we kind of like went over it like a little bit inside like a little diagram. So if we just had a leaf, we passed in like a 1 right here. There are no branches to really check if they're like, balanced or not. And like, each branch has the same sum of all elements because there are like no branches. And so in this case, we're going to return true. So that's going to be our base case right here. If is leaf t, return true. So that's like a tried and true base case. And it's like typical for like tree recursion problems. Return true. And otherwise, what do we want to do? Well, we want to go through each branch and check if it's balanced, along with if its sum is equal to like the sum tree of like the first branch. And so we're going to do for b and branches of t. And then we want to check for 2 conditions. And then so we want to check if it's balanced and if the sum is equal to like the sum of the first few things, sum of the first tree. So we want to check if not balanced of t. But yeah, so I guess like one idea I want to point out right here is like, let's say not balanced. So let's say this like tree, we have like some like bunch of like branches and we find out that one of them is not balanced. Well, if it's not balanced, then we know that we can stop right there because like if one branch isn't balanced, then we have to stop immediately. But let's say we see that one branch is balanced. We don't want to immediately return true. We want to check all branches because like the next branch that we check could be not balanced. And so what we want to do is that when we ever see a not balanced tree, then we want to return false. But if it is balanced, we want to keep going. And same with like checking like the sum of the branches, comparing it to like the first branch. If the sum is equal, then like, we're gonna keep going because like maybe all the other sums could not be equal. But if it isn't equal, we know for sure because like maybe this branch is gonna be 5, maybe this branch is gonna be 6. If they're not equal, we definitely know that like the tree is not balanced, so we're gonna return false. And so we're gonna check if not balanced of t, so our recursive call right here, return false. And then along with that, if the sum of that tree, of that branch, is not equal to sum tree, the sum of the tree of the first branch, so branches of t, indexed at 0, then we're going to return false right here. And what's going to happen is we're going to go through every single branch. We're going to check, is this branch like equal to like the first branch? If it's not, we're going to return false. And then once again, we need to check if that branch is balanced. And once we've gone through all the branches, everything checks out. We're going to return true at the very end because everything seems to be balanced. And yeah, that's going to be our balanced function. And the challenge does say try to write it in one line. So I don't really remember. Let's see. How would I write it? Let me think about it. And so I'm guessing what I would do is I would write return. So this is the one-liner that I'm writing right now. And we need to make sure that the condition for each branch is going to be that, the sum is equal to the first one. And then along with that, we also need to check if if it's a leaf in the first place. Because if it's leaf, we can't make those checks of branches of t indexed at 0 because there is no branch to talk about in the first place. So we're gonna return true. So we're gonna return is leaf of t or something. And so if it's a leaf, it's gonna terminate right here and it's gonna return true. But otherwise, it's going to keep on going, sort of like our short-circuiting method. And so if it isn't a leaf, we want to go through each of the branches and make sure all of them satisfy some condition. So we're going to put an all right here, and we're going to throw a list comprehension right here. And so we're going to have a list of booleans, and each of them is going to have some true value saying is our sum equal to the first branch's sum, and is it balanced? And if it isn't, then it's going to be false, and the all is saying all of them have to be true. And so if there's one false value in there, if it's not balanced, then we're going to, this all thing is going to return false, and our statement is going to be false. And so it's going to be all sum tree of b is equal to, because we want to make sure that it's true. And I'm going to just bring it down here. Sum tree is equal to the sum tree of the first branch, and we want to check if it's balanced. Oh, I just forgot. Balance the B, not balance the T. Sorry about that. We should be checking if the branch is balanced, not if the tree is balanced. And so we also want to check if that tree is also balanced, so balance the B. And then we want to make it so that we go through each branch. So for B and branches of T. And so we're going to go through each branch, check if it's the sum is equal to the first branch's sum, along with if the branch is balanced. And then if all of them are true, we're going to return true. Otherwise, we're going to return false. Yeah, this is going to be balanced. I know I messed up a little bit on this. So if you ever have any questions, feel free to ask me. And